Hello, folks. Pardon the low resolution. That has to do with the amount of light I'm getting right now. Anyways, once we change to some generally brighter scenery, that'll all change. So today we're talking about connective tissue, which binds and separates other tissues and organs. They form the supporting framework of the body. They insulate and transport. So the cells are generally widely separated in a non-living extracellular matrix. The matrix is produced and maintained by the scattered cells. It is the matrix which determines the tissue's characteristics. So for this, there's all these different types of connective tissue, like fat, eyes, I believe, I might have that wrong. But blood is connective tissue, cartilage, bone, regular connective tissue, pretty straightforward, areolar connective tissue. Anyways, for today's lab, we're only going to be looking at these three examples: areolar connective tissue, cartilage, and bone. First up is areolar, so pretty stringy, fibrous, pink. All of these little blobs, those are the main bodies of the cells. You're seeing the nuclei there. So let's go ahead and check that out on our real life example. Oh man. Here, let me turn up the light. All right, that's about what it looks like to me too, when I look at it through the microscope. Right there. So very fibrous, you see exactly what you would hope to see for the tissue holding stuff together, right? Yeah, looks pretty durable, pretty strong. Like if that were a fabric, you would have a hard time ripping it, right? Something crazy like that. Anyways, back to this PowerPoint. So most importantly there, you notice it's a pretty dead ringer for our image over here. All you need to be able to do for this is be able to recognize that this is areolar connective tissue. So connective tissue. If you see this, be sure to be able to identify it. Sound good? So next up is cartilage. All right, here we go. We have some cartilage sampled from the trachea. I'm not sure if it's human or not. I'm not sure I could tell either. It's got to be from something big, probably, though, I imagine. So real quick, let me show you what I'm looking at low resolution. So if we were doing this lab in person, this could be a very confusing slide, because when we look at this, we got a whole bunch of stuff going on here. And if I'm being perfectly honest here, not all of it is our cartilage. Okay, so you need to be able to pick out which of all of this is our cartilage, which of this looks like the picture. So if we go back to our picture real quick. Right there. See, it's kind of pink, looks pretty solid, and then the cells almost look like they're in hollow places. So that is the body of the cell, the little nucleus in it. You can see some out of focus. That's because they're further into the subject. So let's go back to our microscope view. So if we scroll up a little bit, we can see right there, this is exactly what we are seeing in our photo, that middle band. So let's zoom in on that. So this is our cartilage. All right, you can see right there, it transitions into another type of tissue. Not sure what that is off the top of my head, but this is your cartilage. See how solid it looks? And you can tell that it's almost like plastic or something there. And then you have these cells embedded in it, not at all fibrous like your areolar tissue that we just looked at, right? Not at all. So if we give you an image like this one that I'm taking right now, you need to be able to identify that this is cartilage. It is connective tissue. All right. So back to our PowerPoint. Next one we're going to be looking at today is bone. So lastly, we have some bone. And if you're wondering how exactly we're getting these really crazy images of this tissue, I invite you, I strongly encourage you all to go out and look up where I can probably start that at a lower magnification. Look up how slides are made with a micro tomb, not tomb like dead people are buried in, tomb like old-fashioned way of saying book. So MICROTOME. So look up how slides are made with that. And what they do is they take tissue like this bone, they set it in wax, and then they shave it off into razor thin slices, and then they lay those razor thin slices onto a slide and mount them in some sort of liquid media and put a little cover slip on it. Anyway, so what you're seeing is a lot of times not so like that epithelium that we looked at way back when, a couple videos back, that was a top-down view. But the rest of this, we've been embedding tissues and slicing it, and so you've been seeing it from the side, and you're seeing a razor thin section of it. And that's exactly what we did with this bone. We took a hunk of bone and we laid it with the grains facing us, and we sliced off a razor thin section of it. And what you're seeing here, let me zoom in, sorry. I haven't switched over to microscope yet. Getting dark here, oh no. All right. So what you're seeing here is bone tissue. And each of these little dark spots represents one of the cells in this connective tissue. And they form these little round bundles by spiraling from the center. And that is how the bone is formed. We can go ahead and zoom in on one of these. Yeah, there we go. All right. That's a really cool image, quite honestly. So I'm going to snap a little picture of that. Always fun. Anyways. Yes, this is our ground bone tissue. You can see on the very edges of it where it's kind of broken off and there's kind of different angles. Anyways, If you see this on the practical, know that you're looking at bone, and remember that bone is connective tissue. All right, join me in the next video for muscle tissues. All right. And here, let me figure this out. Oh yeah, it's still dark here. All right. And until next time, see you later.